Let us solve a question on limits. This question was asked by a brother on Telegram. We have to evaluate this function, that is limit as x tends to e is the Euler number here. We have the function x minus e upon log of x with base e minus 1. We need to evaluate this very limit. Okay, so let's take the limit of the numerator first. Okay, if I take limit x tends to e of numerator, that means x minus e, so this will become, as x approaches to e, so this function will become e minus e, which comes out to be 0. And let's take the numerator, the limit of the denominator, that means limit as x approaches to e, log of x with base e minus 1 will become log of e with base e minus 1, and this is log of e. We know it is equal to 1, so we get 1 minus 1 is equal to 0. Okay, when we take the limit of this function, we get this as 0 upon 0, which is indeterminate form. Okay, indeterminate form. Okay, when we have a function in indeterminate form, we use L'Hopital's rule, okay, to get rid of this indeterminate form. Or in other situations we will get infinity upon infinity, that's also called the indeterminate form. Now when we encounter this indeterminate form, what we do, we use the L'Hopital's rule, that means L'Hopital's rule. It simply says, if we have, let us say, limit x tends to c f of x upon g of x. Okay, if I evaluate this function, okay, and if I get the indeterminate form, then to get rid of this indeterminate form, we take the derivative of numerator and denominator and then apply this limit, okay, to get rid of the indeterminate form. That means limit x tends to c, so we take the derivative f dash x upon g dash x, okay, and evaluate it as x approaches to c. If we get rid of the indeterminate form, then it's okay. If not, then we take the second derivative. Okay, if still we get the indeterminate form, we take the third, and so on and so forth. Okay, so in our question the process is same. Since we got the indeterminate form, let us say this is f of x, this is g of x. So to get rid of this indeterminate form, the function is candidate to L'Hopital's rule. Okay, so we compute derivative of numerator and denominator. That means we write limit x tends to e of this function x minus e upon log of x with base e minus 1 is equal to limit x tends to e. Okay, so let me use another color. Okay, and then we take the derivative of d upon dx of x minus e divided by d upon dx of log of x with base e minus 1. Okay, so which comes out to be limit x tends to e. Now the derivative of x is 1 here, so we are left with only 1 here, and derivative of e will be obviously 0. And in the denominator, the derivative of log x comes out to be 1 upon x. Okay, and derivative of this will be, since it's constant, its derivative is 0. Okay, and when we simplify it again, this will come out to be limit, okay, limit x tends to e. So 1 upon x, I can write it like this, x, which gives us, now just put x is equal to e, so we get the value of this function is e. That means the limit of this function is x approaches to e is equal to e. Okay, I hope I make myself clear. Thank you.